Hello bachcho. So today we are going to discuss the 8.4 exercise of trigonometry class 10th. We have already covered the question number 1, 2, 3, 4 in our last video. So check out. Now we are starting with question number 5, first part. So the question number for 5th is cosec theta minus cot theta whole square should be equal to 1 minus cos theta divided by 1 plus cos theta. So we have to prove this identity. First we have to remember those three formulas in this chapter 8.4 they are going to use anytime. So these are cos square theta plus sin square theta is always equal to 1. I hope you will remember 1 plus, not mobile phone, 1 plus tan square theta should be equal to 1, and the third one is your cot square theta plus 1 must be equal to cosec square theta, and this one 1 plus tan square theta is equal to sec square theta actually. So let's go ahead. From starting of LHS, there is cosec theta minus cot theta whole square, right? So what we have to do, since we cannot use any squaring identities right now, so our best trick is to convert this function into sine and cos form. So what we will do, there is a direct relation of cos theta with sine theta, so we can write down 1 upon sine theta minus cot can be written as cos theta upon sine theta whole square. Now at the third step, what we will do, we will take out the LCM. So the LCM will be sine theta. It will become 1 minus cos theta above whole square. Now we can separate the square. How we can separate the square? This square will goes on every part, like 1 minus cos theta whole square, separating the square, and sine will become sine square theta. Okay, so what we need to do now, since above it is 1 minus cos theta and downward sine square theta, so I have a trick to convert, like 1 minus cos theta whole square sine square theta can be using first identity. I can write down 1 minus cos square theta, or I can use 1 square minus cos square theta. So I can use the identity a square minus b square is equal to a plus b, a minus b. In this case this is a and this is a square minus b square, so I can write down like that 1 minus cos theta upon 1 plus cos theta. Why I am doing this with respect to the RHS? Always check the RHS what you need to find out, so you can do this. Now above it is 1 minus cos theta whole square, below it is 1 minus cos theta, so I can cut down 1 and the answer will be 1 minus cos theta upon 1 plus cos theta, and that will be your RHS. So I hope you get this question. You can check once again. Cosec theta minus cot theta. Since we cannot use the identity of square, we are just converting into sine theta and cos theta form. So cosec can be written 1 minus sine and cot can be written cos by sine. Now taking the LCM, this step will come by LCM. After taking LCM, we are separating the square. This method is called separating the square. So it will goes on every part. Then since we have to take out 1 plus cos theta at the downward, in the RHS it is 1 plus cos theta. So what we will do, we will use this identity, and after using this identity we will get our RHS. And it is one of the toughest question of 5th part, question number 3rd. Tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta should be equal to 1 plus sec theta cosec theta. So there are number of methods to solve it, but the hint is given we have to convert this into sine and cos term. So yeah, we know this method. Okay, so let's convert it and start. Tan theta can be written as sine theta upon cos theta divided by 1 minus cos theta upon sine theta. This is your LHS I am writing down. Okay, we'll starting from the LHS, plus cot theta can be written as cos theta upon sine theta divided by 1 minus sine theta divided by cos theta. So what we need to do here, we need to take the LCM. So let's take the LCM first. Sine theta divided by cos theta divided by, if I take the LCM here, sine theta, it will become sine theta minus cos theta plus cos theta and sine theta. If I take the LCM here, cos theta, this will become cos theta minus sine theta. Okay, now what we need to do here, the sign will goes up, the sign will also, cos will also goes up, so it will become sine square theta divided by cos theta sine theta minus cos theta plus cos square theta divided by, this sign will comes here, sine theta cos theta minus sine theta. Okay, so let's do the next step. So after taking out the common cos theta sine theta minus cos theta, here I can written down okay, so cos square theta divided by, if I take out common from this minus 1, so it will become minus sine theta and sine theta minus cos theta. Now what you need to do here, take out the LCM. So you will take out the LCM, this will become cos theta sine theta and sine theta minus cos theta, and this minus sign will change this sign, so sine square theta, and since we have taken the LCM, so it will multiply sine cube theta. Okay, plus, but this will become minus sine, so cos cube theta. Now we need to use the identities a cube minus b cube. What it will be, a cube minus b cube is a minus b, a square plus b square plus ab. Okay, so we can use this identity. Here a is your sine cube, sine is your a sine theta, and b is your cos theta. So we can use this identity, sine theta minus cos theta sine square theta plus cos square theta plus sine theta cos theta divided by cos theta sine theta minus cos theta. Here you can cut down this, and sine square theta plus cos square theta will become 1. So after it will become 1, so you have to write down like that, 1 plus sine theta cos theta divided by cos theta sine theta. Now separating this term, 1 upon sine theta cos theta upon cos theta sine theta it will cancel out and become 1, and 1 upon cos theta can be written as sec theta, and 1 upon sin theta can be written as cosec theta plus 1. So this will be your RHS. Let me tell you once again, and then you can go through it. It's a very big solution. You can take out the screenshot. We will start it from here. Third part, first converting into sine and cos, then taking out the LCM. After taking out the LCM, this sine will goes up and it will become sine square cos square theta, and after that sine cube minus cos cube theta. So you can use these identities. Okay, thanks for watching and subscribe. Cos A, okay, cos A upon 1 plus sin A plus 1 plus sin A upon cos A. We need to prove this to sec A. So what we will do here, since this function is already in the form of sine and cos, and we need to convert it into sec, so what we will do, we will take the LCM, basic thing. We will start with the LHS. 1 plus sin A cos A, we have taken the LCM. So this sin A is already crossed, so cos multiply cos, cos A multiply cos A, that will be cos square A, plus this will already cross, so 1 plus sin A whole square. Now I can see I need to find out 2 sec A's. So what I will do, I will open the square by using the property A plus B whole square, that is your A square plus B square plus 2AB. So cos square A plus 1 square 1 plus sin square A plus 2 into 1 into sin A, that will be 2 sin A, divided by 1 plus sin A cos A. Now what we need to do here, cos square plus sin square, this and this I can write down 1. So using the identity cos square A plus sin square A can be equal to 1, right? After writing it down, 1 plus 1, already 1 is here, plus 2 sin A divided by 1 plus sin A and multiply by cos A. So what we need to do here, now I get it. If I take the 2 common out, 2 plus 2 sin A, I think I will get my answer. So let's see how it can be done. So 1 plus sin A multiply by cos A. So we can write down 2 common. So 1 plus sin A upon 1 plus sin A into cos A. Sin cancel, and 2 upon cos A will give you 2 sec A. That will be your RHS. And it's proved.